Right now, as you sit comfortably watching this, something is being boiled alive at 400 degrees Celsius and thriving. Something else is being crushed under pressure that would instantly kill you, yet it's reproducing at rates that would make rabbits jealous. And somewhere on this planet, a creature just died and came back to life, not once, but for the 100th time this year. The most extreme torture chamber ever designed isn't in some dystopian nightmare or medieval dungeon. It's planet Earth itself. And the inmates aren't just surviving, they're winning. They're not just adapting, they're conquering. They're not just living, they're rewriting the very definition of what life can be. You think you know what's possible. You think you understand the limits of survival. You think you've seen everything nature can throw at living creatures. You're wrong. Spectacularly, completely, mind-bendingly wrong. Let me introduce you to the wood frog, a creature that has turned death into an art form. Every winter, when temperatures drop below freezing, this frog doesn't just hibernate, it dies. Completely, utterly. By every scientific definition we have, its heart stops beating. Not slowing down, not beating irregularly, it stops. Complete cardiac arrest. Its blood crystallizes into sharp ice formations that should shred its organs from the inside out. Its brain activity ceases entirely. No thoughts, no dreams, no neural activity whatsoever. Its breathing stops. Its metabolism shuts down to zero. If you hook this frog up to every medical device in a hospital, every single one would declare it dead. Flatline, game over. But here's where it gets interesting. And by interesting, I mean absolutely terrifying in its implications. Spring arrives, temperatures rise, and the wood frog wakes up. Not slowly, not gradually. It simply returns to life, as if death was nothing more than a particularly deep sleep. Its heart starts beating, its blood flows, its brain fires up. It hops away to find a mate and reproduce. How is this possible? The wood frog has developed the most extreme survival strategy on Earth. It floods its body with glucose, essentially turning itself into a living popsicle with biological antifreeze. But here's what scientists only recently discovered, and it changes everything we thought we knew about survival. The frog doesn't just survive freezing. It uses death as a deliberate strategy. It's not an accident or a last resort. It's a choice. The wood frog has evolved to die on purpose because death is easier than staying alive through winter. This creature looked at the harsh reality of winter survival, finding food, staying warm, avoiding predators, and evolved a solution: temporary death. What would drive an organism to that extreme? What conditions would have to exist for death to become preferable to struggling through difficulty? But the wood frog isn't alone in this madness. The Arctic ground squirrel has taken the concept of extreme survival and pushed it into the realm of the impossible. This animal supercools its body below freezing without actually freezing, a biological impossibility that it somehow makes routine. During hibernation, the Arctic ground squirrel's body temperature drops to -3 degrees Celsius. That's below the freezing point of water. It should be dead. Its cells should be destroyed by ice crystal formation. Its organs should cease to function. Yet somehow, it maintains this temperature for months, burning through fat reserves while technically being colder than frozen. Scientists call this supercooling, and for decades, they couldn't explain how it was possible. The breakthrough came when researchers realized the squirrel wasn't just surviving impossible temperatures, it was controlling them. It can regulate its body temperature with precision that would make a thermostat jealous, maintaining the perfect balance between frozen and functional. Imagine if humans could control their body temperature like this. We could survive in space without heating systems. We could live in the Arctic without shelter. We could reduce our metabolism to almost nothing during times of scarcity. How would this change human civilization? Would we still need buildings? Would we still need agriculture? Would we still need each other? The Siberian salamander takes this insanity even further. Scientists have found individual salamanders frozen solid in permafrost for over 90 years. When thawed, they simply wake up and go about their business as if nothing happened. 90 years. Some of these salamanders were frozen before your grandparents were born. But here's the disturbing part that keeps biologists awake at night. These creatures aren't just surviving extreme cold. They're expanding their range. They're becoming more successful, more numerous, more dominant in their ecosystems. The wood frog population is exploding across North America. The Arctic ground squirrel is conquering new territories every year. What if the secret to ultimate survival isn't avoiding death, but embracing it? What if our fear of death, our desperate clinging to continuous consciousness, is actually what makes us weak? The Antarctic midge takes this philosophy to its logical extreme. This insect can survive being frozen solid for years, dried out completely, and then rehydrated and thawed. It can lose 95% of its body water and still come back to life. It can survive temperatures that would kill almost every other creature on Earth. But the most mind-bending aspect of these frozen survivors isn't their ability to cheat death. It's their complete indifference to it. They don't struggle against freezing. They don't fight the process. They simply accept it, embrace it, and use it as a tool. Think about the last time you faced a seemingly impossible situation. Did you fight it? Did you struggle against it? Did you exhaust yourself trying to force a solution? Now imagine if you could approach that situation like the wood frog approaches winter, not as something to be conquered, but as something to be used. The implications are staggering. If organisms can routinely survive complete metabolic shutdown, if they can come back from clinical death, if they can treat freezing as a lifestyle choice rather than a death sentence, what does that say about the nature of life itself? Recent research has revealed that these freeze-tolerant animals don't just survive the freezing process, they've evolved to require it. Remove the freezing cycle, and many of these creatures actually become less healthy, less fertile, less successful. They need death to truly live. Scientists are now studying these organisms to understand aging, preservation, and the possibility of suspended animation for human space travel. But the real question is not whether we can replicate their abilities. It's whether we can replicate their mindset. These creatures have looked at the most extreme conditions on Earth and found a way not just to survive them, but to thrive because of them. They've turned obstacles into opportunities, problems into solutions, death into life. What would you accomplish if you stopped seeing extreme conditions as barriers and started seeing them as tools? How hot does something have to be before it becomes impossible for life to exist? The answer will shatter every assumption you have about the limits of survival. There might not be a limit. Picture this. You're standing next to a hot spring in Yellowstone National Park. The water is bubbling and steaming at temperatures that would cook you alive in seconds. The heat is so intense, you can't get within 10 feet without feeling like your skin is about to blister. This is nature's version of hell on Earth. And it's absolutely teeming with life. Deep in these thermal pools, at temperatures that would denature your proteins and boil your blood, something is not just surviving, it's having the time of its life. Thermus aquaticus lives in water at 85 degrees Celsius. That's 185 degrees Fahrenheit. That's nearly boiling point. Water at this temperature would give you third-degree burns instantly. But for Thermus aquaticus, this is room temperature. It's comfortable. It's home. But that's nothing compared to what scientists discovered in the deepest, hottest parts of the ocean. Meet Pyrococcus furiosus, the furious fireball. This organism doesn't just tolerate extreme heat, it throws parties at temperatures that would kill almost everything else on Earth. Pyrococcus furiosus lives at 100 degrees Celsius. That's literally boiling point. Water at this temperature turns to steam. Your blood would boil. Your brain would cook. Your organs would shut down in seconds. And this organism cannot survive in temperatures that wouldn't kill you. It literally dies if the temperature drops below 70 degrees Celsius. What you consider scorching hot, it considers freezing cold. These creatures use heat the way we use food. The hotter it gets, the faster they reproduce. The more extreme the temperature, the more energy they have. They've turned our definition of hell into their paradise. But here's where it gets truly disturbing. These organisms are not rare exceptions, hiding in a few isolated hot springs. They're everywhere. Scientists have found them in volcanic vents, geothermal fields, deep-sea thermal vents, and even in the cooling systems of nuclear reactors. Yes, you heard that right. There are organisms living in nuclear reactors, eating radiation and loving it. Deinococcus radiodurans can survive radiation doses that are 3,000 times higher than what would kill a human. It lives in the cooling pools of nuclear reactors, where it feeds on radiation and reproduces at rates that would make bacteria jealous. It's essentially a living radiation detector that thrives in environments that should be sterile death zones. Imagine if humans worked the same way these organisms do. Instead of sweating when it gets hot, we became more energetic. Instead of seeking shade, we sought out heat sources. Instead of avoiding radiation, we used it as fuel. What would our cities look like? Our technology? Our entire civilization? The Pompeii worm, named after the ancient city destroyed by volcanic eruption, has taken extreme heat tolerance to a level that defies physics. This creature lives next to volcanic vents on the ocean floor, where temperatures reach 175 degrees Celsius. That's hot enough to sterilize medical equipment. But here's the part that makes scientists question everything they know about biology. The Pompeii worm's head is in water, hot enough to kill almost any organism on Earth, while its tail is in water that's near freezing. It's literally living between fire and ice simultaneously. Its head is at 80 degrees Celsius. Its tail is at 20 degrees Celsius. That's a 60-degree temperature difference across a body that's only a few inches long. Imagine if your head was in an oven while your feet were in a refrigerator, and you were not only surviving, but thriving. How does it do this? The Pompeii worm has developed the most sophisticated biological thermal regulation system ever discovered. It produces its own insulation, regulates blood flow with incredible precision, and has proteins that function at temperatures that would destroy normal biological molecules. If we could engineer humans to survive extreme heat like the Pompeii worm, would we still need air conditioning? Would we need to fear climate change? Would we expand into desert regions that are currently uninhabitable? Or would we become something no longer recognizably human? The most extreme heat-loving organism discovered so far is Methanopyrus candleri, which lives at temperatures up to 122 degrees Celsius. At these temperatures, water doesn't just boil, it turns to superheated steam. The pressure required to keep water liquid at this temperature is enormous. This organism lives in deep-sea hydrothermal vents where the pressure is crushing and the temperature is literally off the charts. It's found in environments that are more extreme than anything on the surface of most planets. But here's the question that keeps scientists awake at night. If life can thrive at these extremes on Earth, what about other planets? What about Venus, where surface temperatures reach 460 degrees Celsius? What about the moons of Jupiter, where volcanic activity creates environments even more extreme than Earth's hydrothermal vents? Recent discoveries have pushed the boundaries even further. Scientists have found organisms living in the reactor cores of nuclear power plants, where temperatures exceed 300 degrees Celsius and radiation levels are thousands of times higher than background radiation. These organisms aren't just surviving, they're thriving. They're reproducing faster in these extreme conditions than their cousins living in normal environments. They've turned humanity's most dangerous technology into their ideal habitat. What if we've been thinking about extreme environments all wrong? What if places we consider uninhabitable aren't barriers to life, but opportunities for life to evolve in ways we can't imagine? The implications are staggering. If organisms can live in nuclear reactors, if they can thrive at temperatures that would vaporize most materials, if they can use radiation as food, then the potential for life in the universe is far greater than we ever imagined. But the real question isn't whether life can survive in extreme heat. It's whether life actively seeks out extreme conditions, because that's where the real opportunities lie. These heat-loving organisms aren't hiding from competition. They're going where no other life can follow. They're not just surviving extreme conditions. They're using those conditions to build biological empires where they have no competition. The tardigrade, our microscopic champion of survival, can survive temperatures from absolute zero to 150 degrees Celsius. But recent experiments have shown that tardigrades actually reproduce faster at temperature extremes than they do in moderate conditions. What if the secret to success isn't finding comfortable conditions, but deliberately seeking out the most extreme conditions you can handle? What if comfort is the enemy of growth, and extremes are where real breakthroughs happen? These organisms have looked at temperatures that would instantly kill most life on Earth and said, "This looks like a great place to build a civilization." They've turned humanity's definition of impossible into their definition of opportunity. The next time you complain about the heat, remember Pyrococcus furiosus throwing a party at boiling point. The next time you think conditions are too extreme, remember the Pompeii worm living between fire and ice. These creatures aren't just surviving hell. They're proving that hell might be the best place to build a paradise. What would happen to your body at the bottom of the ocean? Let me paint you a picture of absolute destruction. At the bottom of the Mariana Trench, the deepest place on Earth, the pressure is over 1,000 times what you experience at sea level. That's like having 50 jumbo jets stacked on top of every square inch of your body. Your lungs would collapse instantly. Your rib cage would crumple like paper. Your internal organs would compress into a ball smaller than a marble. Your bones would shatter into fragments. Your blood would be squeezed out of your vessels. You would cease to exist as anything recognizable. The pressure down there is so intense that it would crush a nuclear submarine like an empty soda can. Steel beams would bend like twigs. Concrete would crumble like sand. Nothing built by human engineering could survive. Yet down there, in that crushing darkness, 7 miles below the surface, there's not just life. There's a thriving ecosystem. There's a party going on, and you're not invited because you're too weak to attend. The Mariana Trench is deeper than Mount Everest is tall. If you could somehow drop Mount Everest into the trench, its peak would still be over a mile underwater. The pressure at the bottom is equivalent to being crushed by a stack of elephants 1,600 elephants high. And it's absolutely full of life. Xenophyophore is creatures that look like alien brain coral crossed with a science fiction nightmare, grow larger down there than anywhere else on Earth. These single-celled organisms, some of the largest single cells ever discovered, can grow to the size of dinner plates. The pressure that would obliterate you is what they need to build their massive, intricate structures. But here's what's truly mind-bending. These creatures aren't just surviving extreme pressure. They require it. Remove them from the crushing depths, and they die. The pressure that would instantly kill you is as essential to their survival as oxygen is to yours. Everything you know about pressure is wrong. You think pressure crushes things, destroys them, makes them smaller and weaker. But what if pressure is actually a tool for building? What if the most extreme pressure creates the strongest structures? What could you create if you had unlimited pressure at your disposal? The deepest fish ever recorded, Pseudoliparis swirelli, lives at depths of over 8,000 meters. That's deeper than commercial jets fly high. The pressure at that depth is over 800 times atmospheric pressure. It's like being continuously run over by a convoy of trucks every second of every day. This fish's body is 95% water, with almost no skeleton. Its bones are so thin, they're almost transparent. Its flesh is gelatinous, almost see-through. It looks like a living ghost, a creature made of water and will. But don't let its delicate appearance fool you. This fish has solved one of the most challenging engineering problems in the universe: how to maintain structural integrity under crushing pressure. Its proteins are engineered to function at pressures that would destroy normal biological molecules. Its cellular structure is optimized for extreme compression. What if humans could survive at the bottom of the ocean? We could mine the deepest parts of the Earth, accessing mineral resources that are currently impossible to reach. We could explore underwater mountain ranges that are more extensive than anything on land. We could live in 3 dimensions instead of just on the surface. How would that change human civilization? Would we still fight over land if we had access to 99% of the planet's living space? The vampire squid lives in oxygen minimum zones, places where there's barely enough oxygen to sustain life. But it's not just surviving in these conditions. It's thriving. When threatened, It can turn its body inside out, revealing spines that make it look like a living nightmare from the deepest circles of hell. This creature has evolved to live in conditions that would kill most other animals: crushing pressure, near-zero oxygen, and complete darkness. It's found a way to extract energy from an environment that should be sterile. But here's the disturbing part. These aren't ancient creatures that got trapped in the deep ocean. They chose to go there. Genetic analysis shows that deep-sea creatures evolved from shallow water ancestors who migrated to the depths because that's where they could thrive without competition. Think about this. These creatures looked at the most extreme, inhospitable environment on Earth and said, "That's where we want to live." They didn't migrate to the depths because they were forced to. They went there because they saw opportunity, where others saw impossibility. The deeper you go, the more extreme the life becomes. At the bottom of oceanic trenches, where tectonic plates meet and the Earth's crust is literally being crushed and recycled, you find organisms that live on the energy released by geological processes. These creatures have tapped into the planet's own power source. They're feeding on the Earth's internal energy, using chemical reactions that occur at extreme pressures and temperatures. They've found a way to live off the planet's metabolism. Barophilic bacteria, pressure-loving bacteria, not only survive at crushing depths but reproduce faster under extreme pressure than their surface-dwelling cousins. The more pressure you apply, the more active they become. They've turned what should be a death sentence into a competitive advantage. Recent discoveries have revealed that the deep ocean isn't just full of life. It's full of life that's more active, more diverse, and more successful than many surface ecosystems. The crushing pressure that would kill you instantly is creating some of the most productive biological communities on Earth. What if we've been thinking about pressure all wrong? What if instead of seeing pressure as something that crushes and destroys, we saw it as something that builds and strengthens? What if the key to creating the strongest materials, the most efficient structures, the most resilient systems, is to subject them to the most extreme pressure possible? The giant isopod, a deep-sea crustacean that looks like an armored pill bug the size of a small dog, lives at depths where the pressure would crush any surface-dwelling creature. But it's not just surviving. It's built like a tank. Its armor is harder than most metals, formed under pressure that would forge diamonds. These creatures aren't just adapted to extreme pressure, they're optimized for it. Their bodies are more efficient, their structures more elegant, their solutions more sophisticated than anything we've engineered. Scientists estimate that 99% of Earth's living space is in the deep ocean. We've explored less than 1% of it. Every expedition to the deepest parts of the ocean reveals new life forms, new ecosystems, new ways of surviving that challenge everything we thought we knew about biology. The most recent discovery is organisms living in the deepest part of the ocean floor, in sediments under pressures that would liquefy most materials. They're not just surviving, they're creating complex chemical cycles that may be essential to the health of the entire planet. What if the secret to building the strongest, most resilient structures isn't to avoid pressure, but to seek out the most extreme pressure possible? What if the key to creating something truly indestructible is to subject it to conditions that would destroy everything else? These deep-sea creatures have figured out something that human engineering is just beginning to understand. The most extreme conditions do not just test strength, they create it. The next time you feel pressured, remember the creatures at the bottom of the ocean who turned crushing pressure into their greatest advantage. They're not just surviving the impossible, they're using the impossible to build something extraordinary. What would it take to kill something that has already defeated death, time, and the basic laws of biology? Meet the tardigrade, the most indestructible animal on Earth, and quite possibly the most indestructible life form in the universe. This microscopic creature, barely visible to the naked eye, has achieved something that every human, every animal, every plant, and every other organism on Earth has failed to do. It has become truly unkillable. The tardigrade can survive in the vacuum of space, not for minutes or hours, but for years. It can withstand radiation doses that are 1,000 times stronger than what would kill you. It can survive temperatures from absolute zero, the coldest possible temperature in the universe, to 150 degrees Celsius. It can go 30 years without food or water. It can survive being completely dried out, completely frozen, completely irradiated, and completely crushed. But here's the part that makes scientists question everything they know about life. The tardigrade doesn't just survive these extreme conditions, it thrives in them. It reproduces faster under extreme stress than it does in normal conditions. It has turned what should be certain death into an advantage. When conditions get tough, the tardigrade does something that redefines what it means to be alive. It expels all water from its body, stops all biological processes, and enters a state called cryptobiosis, literally hidden life. In this state, it's neither alive nor dead. It's something else entirely. Scientists have taken tardigrades in cryptobiosis and subjected them to conditions that would sterilize spacecraft. They've been frozen to absolute zero, heated to temperatures that would melt lead, irradiated with doses that would kill elephants, and exposed to the vacuum of space. After decades in this state, scientists add water, and the tardigrades simply wake up and go about their business as if nothing happened. Imagine if you could pause your life whenever things got difficult. When you faced a challenge too big to handle, you could simply shut down all your biological processes and wait it out. Would you still grow as a person? Would you still be human? Or would you become something else entirely? Something that experiences time differently, that relates to mortality differently, that exists in a way we can't comprehend. But the tardigrade isn't the only creature that has defeated death. The immortal jellyfish, Teratopsis dohrnii, has achieved something even more disturbing. It has made aging optional. When this jellyfish gets old, instead of dying, it reverses its aging process and becomes young again. It's not just extending its life, it's reversing time. It can do this forever. Theoretically, every immortal jellyfish that has ever lived is still alive somewhere in the ocean. Think about the implications of this. Scientists have been studying individual jellyfish for over 20 years. They've watched the same organism be born, grow to maturity, age, and then reverse the process and become young again. They've seen this cycle repeat dozens of times in the same individual. The immortal jellyfish doesn't just live forever. It experiences every stage of life repeatedly. It's been a juvenile more times than you've had birthdays. It's been sexually mature more times than you've changed jobs. It's experienced its entire life cycle more times than you've experienced seasons. This isn't just biological immortality. It's biological time travel. The jellyfish can return to any previous stage of its development at will. It's like having a reset button for your entire life. Deinococcus radiodurans, known as the world's toughest bacterium, has taken the concept of unkillable to a molecular level. This organism can survive radiation doses that would kill humans, most animals, and even most other bacteria. But here's the truly remarkable part. When radiation completely destroys its DNA, shredding its genetic material into fragments, it can perfectly repair itself in just a few hours. Imagine if your body could repair any damage instantly. Not just cuts and bruises, but damage to your fundamental genetic code. Imagine if you could be exposed to radiation that would kill most life on Earth, have your DNA completely destroyed, and then rebuild it perfectly with no loss of information. What if humans could repair DNA damage instantly like Deinococcus radiodurans? We could survive in space without protection. We could live near nuclear reactors without fear. We could potentially become immortal, as aging is largely caused by accumulated DNA damage. But would we still be human, or would we become something else entirely? The Greenland shark has achieved a different kind of immortality. It simply refuses to age quickly. These sharks can live for over 400 years. Some individual sharks alive today were swimming in the ocean when Shakespeare was writing his plays. They've lived through the entire history of the United States, the Industrial Revolution, 2 world wars, and the digital age. But the most disturbing aspect of these long-lived sharks isn't their lifespan, it's their complete indifference to time. They move slowly, age slowly, and exist in a biological timeline that's completely disconnected from the rest of life on Earth. They experience decades the way you experience months. The Antarctic moss Bryum argenteum has been found alive after being frozen for 1,500 years, 15 centuries. This moss was alive when the Roman Empire was falling, when the Vikings were exploring the world, when the first universities were being founded. It was frozen in ice for longer than most civilizations have existed, and when scientists thawed it, it simply resumed growing. What if you could survive being frozen for 1,500 years? You could experience the rise and fall of entire civilizations. You could witness the long-term evolution of species, climate, and geography. But would you still be you after experiencing time on such a scale? Would your consciousness, your identity, your sense of self remain intact? Bedelloid rotifers, microscopic animals that look like tiny wheels, have survived for 80 million years without sex. They reproduce only through cloning, which should make them evolutionarily stagnant and vulnerable to extinction. Instead, they're one of the most successful groups of animals on Earth. They've survived multiple mass extinctions, ice ages, and dramatic changes in Earth's climate. They've been around longer than most species, longer than most genera, longer than most families of animals. They've achieved evolutionary immortality by refusing to play by evolution's rules. But the most mind-bending discovery is that these creatures do not just survive extreme conditions, they actively seek them out. Recent research has shown that many extremophiles, organisms that thrive in extreme conditions, are actually more successful, more diverse, and more innovative than their cousins living in normal environments. The tardigrade, for example, has evolved more sophisticated survival mechanisms than any other animal its size. The immortal jellyfish has developed the most complex life cycle of any cnidarian. Deinococcus radiodurans has the most advanced DNA repair mechanisms known to science. What if the secret to becoming truly successful isn't to avoid challenges, but to seek out the most extreme challenges possible? What if the organisms that face the greatest threats develop the most sophisticated solutions? The most disturbing part is not that these creatures are unkillable. It's that they're becoming more common. As Earth's climate changes, as radiation levels increase, as environments become more extreme, the unkillable organisms are thriving while normal organisms struggle. Climate change, which threatens most life on Earth, is actually benefiting tardigrades. They're expanding their range, increasing their population, and becoming more genetically diverse. The conditions that threaten human civilization are opportunities for the unkillable. Recent studies have shown that tardigrades can survive not just in space, but in the conditions found on other planets. They can survive the radiation levels on Mars, the temperature extremes on Venus, and the chemical composition of Jupiter's moons. They're not just Earth-hardy, they're universe-hardy. If a microscopic animal can survive the vacuum of space, if a jellyfish can reverse aging, if bacteria can rebuild their DNA from scratch, what's stopping you from becoming unkillable in your own way? These creatures haven't just survived the impossible, they've made the impossible routine. They've turned death into a temporary inconvenience, aging into a choice, and destruction into an opportunity for rebuilding. The question isn't whether you can become physically unkillable like the tardigrade. The question is whether you can become psychologically unkillable, emotionally unkillable, spiritually unkillable. What would you attempt if you knew you couldn't truly fail? What would you build if you knew it couldn't be permanently destroyed? What would you become if you knew you could always rebuild, always recover, always come back stronger? The unkillable organisms have one thing in common. They don't just survive extreme conditions. They use extreme conditions to become stronger, more resilient, more capable than they were before. They've turned adversity into advantage, challenges into opportunities, and the impossible into the inevitable. What happens when life runs out of impossible things to survive, and starts creating new impossibilities to conquer. In the last decade, scientists have discovered life forms that shouldn't exist according to our understanding of physics, chemistry, and biology. We're not just finding organisms that survive extreme conditions. We're finding organisms that have evolved abilities that seem to violate the fundamental laws of nature. Organisms that have learned to manipulate time at the cellular level, speeding up and slowing down their biological processes to exist in different temporal states than the rest of reality. Bacteria that have developed biological quantum computers, processing information using quantum bits instead of traditional biochemical reactions. Fungi that create living networks spanning continents, acting as planetary nervous systems that can process and transmit information faster than the internet. The electric eel has evolved the ability to generate up to 600 volts of electricity, enough to power a small appliance. But recent discoveries have revealed that electric eels aren't just generating electricity for defense or hunting. They're using electricity to communicate with each other across vast distances, creating electrical networks in the Amazon River system. These eels can coordinate their behavior across miles of river, sharing information about food sources, threats, and mating opportunities through electrical signals. They've created a biological internet running on bioelectricity instead of fiber optic cables. The electrical networks created by electric eels are more sophisticated than most human communication systems. They can transmit complex information, store electrical patterns for later retrieval, and even amplify signals by working together. But the most extraordinary discovery is organisms that appear to be deliberately evolving new abilities in real time. Scientists studying extremophile bacteria have found populations that develop new survival mechanisms within days of being exposed to previously unknown extreme conditions. These bacteria aren't just adapting, they're innovating. They're creating biological solutions that have never existed before in Earth's history. They're pushing the boundaries of what's possible for life itself. Caldalkali Bacillus thermarum lives in alkaline hot springs, where the pH is so high it would dissolve human flesh. But this organism doesn't just survive these conditions, it's learned to manipulate them. It can alter the chemistry of its environment, creating microenvironments with different pH levels for different cellular processes. It's essentially terraforming its own habitat at the microscopic level, creating custom environments optimized for its survival and reproduction. What if humans could manipulate our environment at the molecular level like this bacterium? We could clean up pollution by changing the chemistry of contaminated areas. We could make deserts fertile by altering soil composition. We could make any environment habitable by reshaping it to our needs. The bombardier beetle has evolved the ability to create controlled chemical explosions inside its body. It mixes two chemicals that would normally destroy living tissue and uses the resulting explosion to shoot boiling liquid at attackers. It's essentially a living rocket engine. But scientists have discovered that the beetle isn't just creating explosions, it's controlling them with precision that rivals human engineering. It can adjust the power, direction, and chemical composition of its explosive spray in real time. Recent research has revealed that the beetle's explosion chamber uses the same principles as modern rocket engines, but with biological materials that are more efficient and more environmentally friendly than anything humans have developed. What if we could learn from the bombardier beetle's biological engineering? We could develop rocket engines that are more efficient, explosives that are more controlled, and chemical processes that are more precise than anything in our current technology. The most disturbing discovery is organisms that seem to be actively working to transcend biological limitations entirely. Scientists have found bacteria that incorporate non-biological materials into their cellular structure, creating hybrid biomechanical organisms. These bacteria can incorporate metals, plastics, and even electronic components into their cells, creating living machines that blur the line between biology and technology. They're not just adapting to human-made environments, they're evolving to become part of human technology. Shewanella onidensis can breathe metals. Instead of using oxygen like most organisms, it uses iron, manganese, and other metals as electron acceptors. But it doesn't just consume metals, it can manipulate them, creating metallic structures and even primitive electronic circuits. This bacterium is essentially a living 3D printer that works with metals, creating structures at the nanoscale with precision that exceeds human manufacturing capabilities. What if we could partner with organisms like Schuanella to manufacture technology? Instead of building factories, we could grow them. Instead of mining metals, we could farm them. Instead of designing circuits, we could evolve them. But the most mind-bending discovery is organisms that appear to be developing collective intelligence. The slime mold, Physarum polycephalum, can solve complex problems that challenge human engineers. When presented with a maze, the slime mold can find the shortest path between food sources more efficiently than computer algorithms. When given a map of cities, it can recreate the optimal layout of transportation networks. It's a single-celled organism that's outperforming human urban planners. But recent research has revealed that slime molds can learn, remember, and teach other slime molds. They're developing a form of distributed intelligence that operates without a brain, without neurons, without any of the structures we associate with thinking. What if intelligence doesn't require brains? What if consciousness can emerge from any sufficiently complex system? What if we're sharing the planet with forms of intelligence we can't recognize because they're so different from our own? The mycorrhizal networks created by fungi connect forest ecosystems in ways that suggest planetary-scale intelligence. These fungal networks can span continents, connecting trees and plants across thousands of miles. Recent research has shown that these networks don't just transport nutrients. They process information, make decisions, and coordinate responses to threats across entire ecosystems. They're like a planetary nervous system, with fungi acting as neurons and forests acting as organs of thought. Scientists have discovered that trees can communicate through these networks, sharing information about diseases, coordinating defensive responses, and even transferring resources to support struggling members of the forest community. What if Earth itself is developing intelligence? What if the extremophile organisms, the bioelectric networks, the fungal communication systems, and the quantum computing bacteria are all components of a planetary consciousness that's beginning to emerge? The organisms we've explored aren't just surviving extreme conditions, they're creating the building blocks of something unprecedented in Earth's history. They're developing capabilities that transcend traditional biology and enter the realm of planetary engineering. Recent discoveries suggest that extremophile organisms are actively working to make Earth more habitable for themselves and less habitable for organisms that can't adapt to extreme conditions. They're not just surviving climate change, they're accelerating it in ways that benefit them. What if the future of Earth belongs not to humans, but to the organisms that have mastered the art of thriving in impossible conditions? These creatures have looked at the fundamental laws of physics, chemistry, and biology and said, "These are suggestions, not rules." They've transcended the limitations that constrain every other form of life and entered territories we're only beginning to understand. They're not just surviving the impossible, they're redefining what impossible means. After witnessing life survive freezing, boiling, crushing pressure, deadly radiation, the vacuum of space, and the violation of physical laws, what's your excuse? Every creature we've encountered today has faced odds that should have been fatal and not just survived, but turned those impossible odds into advantages. They've made death optional, aging reversible, and the laws of physics negotiable. The wood frog dies every winter and comes back stronger. The tardigrade survives in space and reproduces faster under stress. The immortal jellyfish has made aging a choice rather than an inevitability. The deep-sea creatures have turned crushing pressure into an architectural tool. But here's the question that should keep you awake tonight. If a microscopic tardigrade can survive in space, if a frog can die and resurrect itself, if a jellyfish can reverse time, if bacteria can eat glass and breathe metal, what could you accomplish if you stopped believing in limitations? Think about the last time you said something was impossible. The last time you gave up because conditions were too harsh, too challenging, too extreme. Now apply the survival strategies we've witnessed today. Could you treat that obstacle like the wood frog treats winter, not as something to fight, but as something to use strategically. Could you approach that challenge like the tardigrade approaches space, with complete confidence in your ability to not just survive, but thrive in conditions that would destroy others? Could you reimagine that problem like the deep-sea creatures reimagined pressure, not as something that crushes, but as something that builds strength? These organisms didn't receive instruction manuals. They didn't have technology, education, or anyone telling them what was possible. They simply looked at what should have killed them and found a way to make it their greatest advantage. What if the greatest limitations aren't imposed by the environment, but by our belief in what's possible? What if every impossible situation is actually an unexplored opportunity for unprecedented growth? The extremophile organisms have revealed something profound about the nature of life itself. There are no true limitations, only untested possibilities. Every boundary can be transcended, every rule can be rewritten, every impossibility can be transformed into an advantage. What would you attempt if you knew that every extreme condition was actually designed to make you stronger? What would you build if you knew that every obstacle was actually raw material for something extraordinary? The tardigrade floating in the vacuum of space isn't struggling against the impossible. It's demonstrating that impossible is just another word for unexplored. The wood frog dying and resurrecting every winter isn't suffering through an ordeal. It's proving that death itself can be turned into a survival tool. The immortal jellyfish reversing its aging isn't defying nature. It's showing that nature has no fixed rules, only infinite possibilities. Tomorrow, when you face your next impossible situation, don't ask, "How can I avoid this?" Ask, "How can I use this?" Don't think, "This might kill me." Think, "This might transform me into something unprecedented." Don't say, "This is too extreme." Say, "This is where real growth happens." Because somewhere out there, in conditions that would obliterate you in seconds, something small and seemingly insignificant isn't just surviving. It's building an empire. It's rewriting the rules of existence. It's proving that the most extreme conditions create the most extraordinary life. These organisms haven't just conquered the impossible. They've revealed that impossible is a human concept that doesn't exist in nature. Nature doesn't recognize limitations. It only recognizes opportunities for innovation, growth, and transcendence. The question isn't whether life can survive anything. Life has already answered that question with a resounding yes to every challenge the universe has thrown at it. The question is, what will you choose to survive? What will you choose to transform? What will you choose to transcend? Because if a microscopic water bear can conquer space, time, and death itself, there's literally nothing stopping you from conquering whatever you set your mind to. The extremophiles aren't just surviving. They're showing you what's possible when you stop making excuses and start making the impossible routine. The next time you think something can't be done, remember that right now, somewhere on this planet, something is doing what you think is impossible, and it's not even trying hard. What's your excuse now?